Make sure to stay tuned to this episode of the AI Show where Manoj Goswami, Principal Program Manager for AI Frameworks, tells us all about the ONNX Runtime, what's new, and even some amazing hardware announcements. Hint, there's partners involved, FPGAs, special guests. Enjoy.
Hello, and welcome to this on-demand session about ONNX Runtime. Today, I'm going to talk about our work with Xilinx to integrate ONNX Runtime with their FPGA solution. I'm Manoj Goswami, a program manager in Microsoft's AI Frameworks team. The Open Neural Network Exchange, or ONNX, is an open source format for representing ML models, both traditional ML and DNNs. There are converters available to convert from different training frameworks to ONNX. By having a common model format, we provide data science teams with the freedom to choose their tools for development and training, while ensuring that their model can be represented in a common way that can be easily deployed and executed. We achieve this by using the ONNX Runtime inference engine to execute ONNX models. On the other hand, having a standard model format allows hardware platform makers to focus on innovation for optimizing neural network computations on their platform. This common format for the machine learning model and the ONNX Runtime inference engine allows us to decouple the data science world of model development from the fragmented hardware execution environments in the cloud and the edge. ONNX Runtime is the open source inference engine to execute ONNX models. It was designed with a focus on performance, extensibility, and scalability in order to support heavy workloads and traffic as a production solution on the cloud and edge. The runtime is optimized to implement all the operators defined in the ONNX spec, and therefore it can run any valid ONNX model. The ONNX runtime supports the notion of a custom operator that can run alongside official ONNX operators, which means that as operators get introduced into the spec, the ONNX runtime is capable of running them even before the spec is standardized. The runtime is backwards and forwards compatible so that as models are updated to newer versions of the offset, the ONNX runtime can execute them. The ONNX Runtime architecture supports this extensible plugin interface called the Execution Provider Interface, and this is used to run models on different hardware optimized environments. We will talk about the ONNX Runtime Execution Provider in a subsequent slide. And finally, ONNX Runtime is integrated inside WinML, which is the ML execution environment in Windows 10. Today, we are releasing an update for the ONNX Runtime Inference Engine version 1.3. This update includes support for ONNX Spec version 1.7. We are announcing the general availability for the DirectML execution provider on Windows. This provides acceleration for ONNX model inference across different platforms on Windows devices. We are releasing a number of other execution providers in preview to support ONNX models across different platforms, expanding our ecosystem. And the Python package for ARM64 devices is going to be published starting this release. Additional details about the version 1.3 release can be found in the ONNX Runtime GitHub page. The ONNX Runtime enables ML model execution on different hardware platforms through the execution provider interface. This allows hardware platforms to integrate with the ONNX Runtime by building an execution provider for that specific compute endpoint. We have a number of execution providers from our hardware ecosystem partners across the breadth of options from CPUs to GPUs and custom neural accelerators. These execution providers are used to execute models in the cloud as well as on edge devices. Today, we are happy to announce a new partner in our growing hardware ecosystem for ONNX Runtime. We have partnered with Xilinx to build the execution provider for the Vitus AI software library. This execution provider is used to execute ONNX models on the Xilinx U250 FPGA platform. Developers can now take advantage of this execution provider to build and execute models on this Xilinx FPGA platform. The Vitus AI software library is the Xilinx development platform for AI inference on Xilinx hardware platforms. The U250 FPGA is available in private preview in Azure as the NPVM SKU for users to use with the Vitus AI software stack. The Vitus AI toolkit consists of optimized IP, tools, libraries, models, and example designs for developers to use with the FPGAs. This allows FPGA developers to infuse AI inferencing and acceleration on the FPGA. Azure provides a wide variety of infrastructure options specialized for your big compute workloads. The Azure NPVM with Xilinx LVO U250 FPGA accelerator is in private preview now. This SKU offers from 1 to 4 Xilinx U250 FPGA devices as an Azure VM backed by powerful Xeon Platinum CPU cores and fast NVMe-based storage. The NP series will enable true lift and shift and single target development of FPGA applications for general purpose cloud applications. This VM is based on a board and software ecosystem for the Xilinx U250 card. The Vitis software stack and ONNX Runtime will run on this Azure VM as well as on other on-prem and edge devices with the Xilinx FPGA. This solution enables the bleeding edge of accelerator development to harness the power of cloud without additional development costs. Xilinx and Microsoft collaborated with PeakSpeed, an innovative startup that provides geospatial analytics solutions to integrate ONNX Runtime and the Vitis AI stack. This solution seamlessly integrates PeakSpeed's deep learning object classification models and uses ONNX Runtime with the Vitis AI execution provider to accelerate the pipeline on the new Azure NP series FPGA platform. To discuss more about the solution, please welcome Oscar Kramer, PeakSpeed's chief scientist.
Thanks, Manash. Here at PeakSpeed, we're very excited to be one of the first users of Microsoft's new NP series Azure VMs for high-performance computing. We've been focused on building the world's fastest geospatial imaging solutions, and Azure NP will enable us to meet some critical demands. Today, I'll be showing PeakSpeed's TrueView and Identify applications that leverage the power of the FPGA for performing compute-intensive operations. Here, we're using Esri's ArcGIS Pro application to illustrate. This image over Estes Park in the Colorado Rockies was provided by Maxar. This area of about 100 square kilometers has high terrain relief, resulting in significant distortions due to the sensor's perspective. Let's fly over to the Stanley Hotel and look at this curved road here. We can see a big offset between the map and the image. To get the image to line up, it needs to undergo a geospatial correction, or orthorectification, that resamples every pixel from the satellite perspective to a map projection. Until now, this was being performed on CPUs, but PeakSpeed, using the FPGA on an Azure NP instance, has managed to accelerate that process considerably. Let's look at the performance numbers. Here are PeakSpeed's DevOps pipeline outputs that we use for benchmarking. These numbers compare TrueView running on an Azure NP hosting the Xilinx U250 FPGA against the same algorithm running on a Xeon Platinum CPU. We're looking at 4 minutes 21 seconds on the CPU versus only 1.7 seconds on the FPGA. Let's go back to ArcGIS Pro and look at the output produced by TrueView. Here's the same image after orthorectification. We'll zoom into the same spot and you can see that now it lines up perfectly with the base map. Let's zoom back out and switch between the two images. This gives you an idea of the highly nonlinear transformation involved. Now that we have an ortho image, we're ready for object detection. This is where the ONNX Runtime running Xilinx's Vitus AI library come in. We'll be using PeakSpeed's Identify training models to detect cars in the satellite image. The production pipeline is implemented in a Python script, and we can easily flip between CPU, FPGA, or GPU via a runtime parameter, depending on our needs. In this case, using an Azure NP instance, customers will see a significant savings in TCO and faster response times. The ONNX Runtime enables PeakSpeed to target a variety of acceleration platforms in Azure, and that helps us provide the best value to our customers. Thanks, and back to you, Manash.
Thanks, Oscar. PeakSpeed was able to deploy their deep learning models on the Azure NPVM, and it's a great performance. The YOLO V3 model showed improvements on the VM relative to GPU instances, and the end-to-end geospatial analytics pipeline ran 4x faster than on a GPU. ISVs and customers can now infuse their applications with deep learning using ONNX Runtime and the Vitis AI stack, and accelerate on the FPGA endpoints in Azure as well as on-prem with the Xilinx U250 hardware. Developers can take advantage of this integration by building the Vitis AI execution provider with ONNX Runtime from source. You can do that from the ONNX Runtime GitHub master repo. Additionally, very soon, Xilinx will release a VM image in Azure Marketplace with all the pre-built software libraries integrated in one place for easy deployment into the Azure NPVM. Thank you for listening, and I hope you have a great day.